else waiting? Okay, let's just wait for a while bagi semua orang lain masuk. I have lost my stylus. Where on earth is it? Siapa? Hazmi, tolong create one column. Everybody please. What do you call this? Sign attendance. While I'm trying to figure out where my stylus is. Sekejap saya kena cari. Okay guys, is it silau nampak? I've just realized I've lost my stylus. Mau tak ngajar, mana pergi letak tau. In the meantime, can you open up? I'm gonna give you 10 minutes. Sekarang pukul 11:12. Can you get 10 minutes to go through the link that I gave you? Boleh? Boleh?
Boleh.
Okay, go through that. We come back here. Let's make it 11:30. Boleh? Okay, go through it. Okay, 11:30 we come back here. I'm gonna write it in chat. Go through the link. Come back 11:30. All right, go now. Hi guys, this is a video for basic fundamentals of Laplace transform. Okay, now, so Laplace transform basically takes in a signal in a time domain. So here I will denote the function of a signal by using a small letter f, okay? And it is actually a process, yeah? The Laplace transform is actually a process that transforms the input signal in time domain and convert it into another signal in the spatial domain. So I just would like to highlight here is in order to differentiate the two signals, for the one in time domain, we use the small letter f for the function. And the one for the spatial domain, we use the capital letter of f to indicate it is a function in the spatial domain. So basically, the formula for Laplace transform is a function in the spatial domain, which is the output of the Laplace transform, is an integration from 0 to infinity. Again, if you have an integral, you have at the end dt, yeah? So your input here, which is the function in the time domain, needs to be multiplied with a kernel function, which is an exponential to the power of negative st. All right, okay. So basically, a Laplace transform here utilizes a kernel function. So exponential to the power of negative st is a kernel function, which is in the form of exponential decay. So the beauty about exponential decay is that when you substitute the value of 0 to infinity, either 0 or infinity, if you substitute the value inside it, it will give you some output, some definite results. All right. This let me just demonstrate you here. This is an example of exponential decay, e to the power of minus t. Let's say we take the general exponential decay function. So when t is at time 0, the exponential decay will cut the y-axis at 1. And as t is approaching infinity, the exponential decay function will actually goes towards 0. Yeah. So I will demonstrate this later with an example. Let's go to example 1. Yeah. Assuming you have a signal which is static in the time domain at 1. Okay. So your function in the time domain ft is equivalent to 1. Now your fs, which is the function in the spatial domain, we will apply Laplace transform, which is an integral function from 0 to infinity. We take in the input signal itself, which is 1, multiply with a kernel function, which is exponential to the power of minus st, and don't forget your dt here. The answer to this will be exponential to the power of minus st over minus s, and the whole thing must vary between the limits, which is from 0 to infinity. Okay, so when we try to substitute this value, let's substitute it first. Exponential to the power of minus s, first we substitute the value infinity. We minus with exponential to the power of minus s, we substitute the next limit, which is 0. Okay, and don't forget it must be over minus s. So if you realize this, coming back to the exponential decay function, when it is at infinity, it is actually 0, and when it is at time 0, it is actually 1. So we can substitute the value here. Let's try to solve this. So you will get 0 minus 1 over negative s, and we can cancel off basically the negative from both sides, top and bottom, and you will get an answer of 1 over s. Okay, it's as simple as that. Okay, now let's go to the next example, something which is slightly more complicated. Assuming you have an input signal which is exponential to the power of at. Now here a itself is a constant. Okay, it can be any value, 1, 2, 3, doesn't matter. Let's assume a is a constant. So your Laplace transform in the spatial domain, again, it is an integral function from 0 to infinity. You take in your input signal, which is exponential to the power of at, multiply with the kernel function, which is exponential to the power of minus st. Okay, and let's try to solve this, since this is a multiplication function, so you can combine both exponential at plus with minus st, and this is dt. Bear in mind, we want to make sure that this is in the form of negative exponential function. Let's try to modify this. We want to make sure that this is in the form of exponential decay function. So exponential decay, you will have negative here, you will have t here, and inside it, in this case, we will have what we call it as s. So negative here, you will get negative s minus a. Okay, so this is your function in the form of exponential decay, and you will get the result, which is exponential to the power of minus in bracket s minus a times with t over s minus a in bracket, don't forget your negative here, and it should vary from the limits, which is from 0 to infinity. Now let's just substitute the value. Exponential negative s minus a in bracket, that is varies from infinity, okay, minus with exponential negative in bracket s minus a, the next limit, which is 0, and all of it is divided by negative in bracket s minus a. So here we can substitute the values. You know, where it is at infinity, it will be 0, and when it is at 0, it will be 1. So the result of this will be negative 1 over negative in bracket s minus a, and we can cancel off the negative of both sides, top and bottom, and your final answer will be 1 over s minus a. So it is as simple as that. Okay, now the two examples which I have shown you basically corresponds to the Laplace transform here. So the first one is this part, yeah, which is given an input 1, your Laplace result will be 1 over s. The second one is here, given an input exponential to the power of at, the result will be 1 over s minus a. Okay, for the next subsequent examples, I will use this Laplace transform table directly. That's it for this video. Thank you. Okay, guys. Have you gone through it? Okay.
Yes.
Is everyone here? Saya hilang lah saya punya stylus tu. Tak mengajar. I don't know where I put all my stuff. Tak apalah. There you are. Okay. Hold on. Yes. All right. Now, I'm gonna call up your name and you present to me, ya. So sekarang ni lecture with regard to the lecture apa nama ni? Lecture what's remaining is Laplace transform. So you can subscribe to my channel if you want. So that is, don't worry, saya cuma post materials regarding Laplace. So that is the lecture material for module 8, 9, 10. I think 8, 9, 10. 11 we've already gone to D'Alembert, which is PDE. So 8, 9, 10 mostly there. So I think if you follow the link, the one I've given you is basically is on dia tulis apa nombor 1 kan? Betul tak? Saya Laplace 1, Laplace 2, Laplace 3. So you follow that way. So hari ni we will do Laplace 1 till Laplace 3. I'm not gonna talk a lot. So basically I'm gonna let you to present. But before that, let me just explain to you your quiz, yeah? I'm gonna share whiteboard. Okay. Semua ada kan ni? Yuhu, Izzat Ganu, Izzat Farid. Ada?
Ada, Doktor.
Ada. Ada 2 Izzat, ada Fadhi. Okay, Fadhi mana Fadhi? Mana
Ada.
lagi satu Fadhi? Ha?
Ada.
Tunjukkan diri. Awak lepas nak present senyap je orang Kelantan ni. Masa saya suruh present group Kelantan ni, korang senyap je. I don't even know that you guys are from Kelantan. Anyway, I'm gonna start with your quiz 3. Let me see if this says, alamak, tak charge ke? Kejap ya, kejap. Oh, damn it. I need to charge. Allahu Akbar. Kejap. Oh, ya Allah. Kalutnya saya sekejap. I'm gonna... Okay, saya tak charge. Kejap ya. This is what happened early of the semester. Kalut. Mana charger pun entah. Oh, never mind. Forget about the tablet. Can I not charge it? Okay, now let me try to write here. Okay. You are being given 2y prime. Ini quiz 3 ya. Pergi tolong tengok quiz 3 dulu. 2y prime plus 3y prime minus 9y equivalent to g1x plus g2x. Right? So now you're also being given that y is equivalent to y complement plus y particular 1 plus y particular 2. And then y particular 1 is equivalent to what was given? E to the power of 3x. Okay. Where else y particular 2 is equivalent to, what was it? Bx plus c. All right. Have a look at your quiz tree, yeah. Tolong buka Putra Blast. Have a look first. Alright, now for all the groups, jawapan for Y particular is the same. So in other words, for Y complement. So this is for YC, okay. For YC, in order to solve YC, first we need to get the CE, which is 2. Mana si Faidahi? Faidahi yang lagi seorang yang tak pernah menjawab tu.
Ya saya.
Okay, bacakan. Apa di YC?
UIC sekejap.
Y complement. Saya nak dapatkan characteristic equation dia, apa dia?
C1.
Tu apa? Tu 2R square. Dah lupa dah?
2R square
Campur
plus 3R
3R
tolak 9 equal to
minus
0.
9 equivalent
0.
0. Okay, this one if you were to do factorization, you get 2R minus 3 R plus 3 equivalent to 0. So what is R1? Right here.
Negative 3.
R1 is equivalent to negative 3 because I've already said that R1 should be less than R2, yeah? So R1 is negative 3 and what is R2?
3/2.
3/2 or equivalent to 1.5. I've told you I want to the dua digit floating points, but never mind. If you give me 3/2, I will try to autocorrect it later on. So this should be the same for all the groups. The only difference is with regards to the ABC. So for group 1, you have G1X is equivalent to 27 e to the power of exponential to the power of 3x. Okay, so in this case, YP1 is equivalent to this. I'm going to copy and paste here. Tak boleh copy and paste. A exponential to the power of 3x. So what is YP2? Find here. Well, YP1 prime.
3A E3x.
3A exponential to the power of 3x. All right. What is YP1 prime prime?
9A exponential power 3x.
9A exponential to the power of 3x. All right. So if you were to substitute this into the top equation, so substitute right here, 2 times
2 times in brackets 9A
9A
exponential to the power of 3x
exponential to the power e to the power of 3x, okay?
plus 3 in
Plus
bracket
3.
in bracket 3A e
3A
power 3x
e to the power of where is it? The power of 3x, all right?
minus 9
Minus 9
in brackets a
in
e
bracket.
power 3x.
You're getting good here. A e to the power of 3x, okay? Equivalent
To 27 power 3x.
e to the power of 3x. So everything is also e to the power of 3x. So what I'm gonna do is because everything is e to the power of 3x, so cancel out. So what is left right here? 2 times 9 is 18. 18A plus
nothing.
3 times 3?
9.
9a.
9a. Equal
The one
to
that I
27.
cancel is the exponential to the power of 3x, okay? Minus,
Minus 27.
hey hang ni. Tengoklah sini.
Minus
This
9.
is 9a.
Minus 9. Minus 9.
Minus
Minus 9.
minus 9a equivalent
Equivalent to 27.
27. What? 27. Okay. So having said this, okay, so this one cancel out each other, so you are left with what? 18a. A
18a
equivalent
equal
to
to 27.
27. Therefore, a is equivalent to 27 over 18,
3 over 2.
which is 3 over 2, which is 1.5. Alright. Boleh? So this is your A. Alright. So now getting, okay, so this is G1x. So let's try G2x. Assuming your G2x is what was given? Mana tadi? G2x for group 1 ialah I think 9x plus 6. 9x plus 6. This is what we given. This is for group 1. Yeah, I'm just doing for group 1 so that you can replicate it for group 2, 3, 4, 5, 6, 7. All right. G2x. Okay. Now, I'm done with that. Okay. So, so now YP2 is equivalent to BX plus say, Fadhi, help me. What is YP2 prime?
Saya group 7.
Okay, salah. Tolong dia. Hang ni.
Okay,
Cepat.
jap. Okay, jap. B.
B. Okay. Okay.
And
What
then
is?
0.
Yeah, YP2 prime? 0. Okay.
0.
Okay, now substitute Fadhi.
2 in bracket 0
2, 0.
plus 3 in bracket B
3 in bracket B
minus 9
minus 9
in bracket BX plus C
plus C
equal to
equivalent
9x plus 6.
9x plus 6. All right. So you will get from here, which is 3b.
3b minus 9bx minus 9c.
9bx minus 9c is C equivalent
to 9x plus 6.
9x plus 6. All right. Betul? So here we're gonna get what? So we're gonna do x first. Okay. So from here, minus 9bx equivalent to yang ada x apa Faithi?
9.
9x. Okay. So from here you can minus, oops. Aduh, alamak. So from here you can basically minus the x. So you are left with what?
B equal to negative 1.
So here B equivalent to negative 1. So done. Okay, this is for B. So now let's substitute for the other one. Okay, I'm gonna do it here. Okay, so which is kita ambil 3B
3b minus 9c equivalent
minus
to 6.
9C equivalent to
6.
6. Okay, sorry, 6. B tadi is equivalent to negative 1 kan? So you have negative 3. Negative 9C equivalent to 6. Okay, so negative 9C equivalent to 9. So your C equivalent to?
Negative 1.
Negative 1. Alright, okay. So dah boleh? Okay. Let me just. So this is how you get the A, B, C dengan R1 and R2. So R1 and R2 should be the same for all the groups. Cuma A dan B dan C berbeza from one group to another. Alright, so can I get a rep? Awak group apa, Faidy?
Group 7.
Okay, Faidy groups. Faidy 1. Awak Kelantan mana, Faidy?
Pasir Putih.
Pasir Putih. Okay, Faidy Q Putih lah. Okay, awak group 7. Faidy lagi satu. Dari mana? The other Faidy. Hello? Where are you?
Yeah.
Where is the other Faidy?
Ada
Awak dari mana?
Black Line.
Hah?
Black Line.
Kuala Kerai. Okay. Kerai. Awak group apa?
Group 2.
Group 2. Alright. Okay. Izzat Ganu. Awak group apa?
Group 4.
Group 4. Izzat. The other one is Izzat. Allah. Parit. Izzat Parit.
Satu.
Awak group apa?
Satu.
Satu. Okay. Siapa lagi tak ada? Haziq Kajang. Awak group apa?
Group 5.
Group 5. Haziq Bangi.
Saya group 4.
Group 4 dah ada. Okay, kita dah ada 1, 2. Siapa lagi should I call? I'm gonna get Pradip. Group apa?
Group 7.
Group 7 is already there. 1, 2. Who is group 3? Group 3. Cecilia. Pontian. Group apa?
5.
Okay, group 5. Group 5 dah ada. Siapa group 3? Siapa group 3 ya? Mimi group apa?
Me. Group 3, Tabina.
Tabina group 3, okay. Tabina group 3. I have 1, 2, 3, 4, 5. Okay, group 6. Who is from group 6? Shafika, PJ. Group apa?
Group 6.
Okay, Shafika. Alright, now I need you to go through the question that I give, the answer scheme that I gave you regarding the R1 is R2 is already fixed. The A, B, and C. Revert back to me. Let me know if they are correct or not. Faham? Boleh? Sebab saya buat semua ni via simulation. By right, it should be correct lah. Tapi you just double check because I do all via simulation. Boleh? Okay? Tabina okay? Izzat Ganu,
Yep,
Izzat Parit.
Okay.
Okay.
Fadahi 1, Fadahi 2, Haziq Kajang, Shafika, do this, alright? Revert back to me by today. Okay, done. We are done here. So that's it for your this. If you give me 3/2, of course I consider it as 1.5 lah. Don't worry so much. Alright. Now, I'm gonna stop viewing this. Alright. Okay. Now, what did you understand by? Macam mana saya nak tutup ni? Okay. What did you understand by multiple participants? By Fatin pun ada 2 Fatin kan? Kan ada 1 Fatin? How many Fatin? Fatin Shah Alam, ada lagi Fatin lain tak? Fatin pun ada 2. Yo, there's so many double here. Fatin Shah Alam. The other is Fatin KB. Okay, Fatin Shah Alam. Fatin Shah Alam mana?
Ya, doktor.
Okay, Fatin Shah Alam, open up your screen. Okay, explain to me daripada video clips tadi. Now it's easy because all my clips are in the YouTube. So what I'll do, I'll give you guys my YouTube link. You explain back to me. Explain to me what is the very basic of Laplace transform and the formula. Cepat. Cepat, Fatin Shah Alam.
Yeah.
What do you understand of Laplace transform?
Laplace transform is uh,
Okay.
the integration of
From 0 to infinity, good. Ft. Cipta lah.
times ft times exponential to the power of negative st.
Awak tulisan macam gajah betul. Gegas kecil sikit. Minus st, okay. Apa yang awak faham ni? Maksudnya dia integrate from what to what? What is the kernel here?
The kernel is e to the power of negative st.
Okay. What does t represent? What does s represent?
T represents time. S represents spatial.
Spatial tu in the space domain, spatial lah, that doesn't matter, okay? Spatial domain. Alright, SPA tulis, SPATIAL. Okay, alright, thank you so much. Alright, okay. That is Fatin Shah Alam. Fatin KB. Fatin KB?
Yes, Doctor.
Okay, Fatin Shah Alam. Okay, Fatin KB, cuba selesaikan when t is equivalent to 1 for your Laplace transform.
Just screen. Screen.
Okay, tulis t sama dengan kosong. T sama dengan tadi apa? Ft equivalent to 1. Okay, find the Fourier the Laplace transform. Laplace Fs sama dengan conteng sajalah.
Draw.
Pakai pen je lah, senang, tak apa. Tulis je. Ft equivalent to 1. Okay, so Fs, the Laplace transform is ui, lamanya. Infinity, good. 1 multiply exponential to the power of minus st. Don't forget dt. Okay. So, which is? Exponential to the power of minus st. Good. Over minus s. Good. Okay. From
Infinity. 0 to
okay.
infinity.
0 to infinity. Good. So substitute.
Mm, yes.
Mhm.
Mm,
Okay.
minus
Mhm.
S
Okay.
from
Okay.
negative F.
All right. Equivalent.
Equivalent
Okay. Substitute. Kalau infinity, exponential decay when you go to infinity, you're approaching
0.
0, right? When you are at 0, you are
1.
1. Good.
0, 0. Minus 1.
Mhm.
Negative S.
So you are left with
1 over S.
1 over s. Good. Thank you, both Fatin. Very good. I'm gonna go to you, Ipoh Malay. You, where are you now? Are you still in Ipoh or college?
Ipoh.
Ipoh. Okay, you. Good. Do me the second example when ft is equivalent to, what was it? 1. No. Exponential to the power of 80.
F
Ft is exponential to the power of 80. Okay, good. Get me the the Laplace transform. Yeah, you have to write Fs. Okay, because that is the product of Laplace transform in the spatial domain. Okay. Right?
sekejap.
From 0 to infinity. Okay. Don't worry, we understand that. E to the power of negative st. All right. Multiply with e to the power of at. Good. Don't forget your dt. dt. Okay. Infinity. Okay. From 0 to infinity. Make it in the form of, yeah, that is correct. At dt. Okay, make it in the form of exponential decay. S negative A, good. Outside is t dt. All right, good. Get me the answer now. So the product is exponential to the power of negative in bracket s minus a t, all right, over minus in bracket s minus a. All right, and this varies from 0 to infinity. Okay, good. So substitute the value of infinity and 0 into your answer. Zero minus e to the power of 0, okay, over Okay. So you will get yeah.
Macam mana nak tukar pencil?
Atas tu tadi. Dekat mana you cari dapat duster tu dekat situ. It doesn't come out, yeah. Does it come out?
Dia bagi.
Just right lah. 1 over S minus A. All right, good. Okay. Thank you, you. How's your parents, you? They're good?
Still good.
They're good.
Semua
Everybody is
stay
good
negative.
at home. Yeah? Okay, good. That orang Ipoh are all good. All right, okay. Now, so you got it. That is basically what Fourier transform is all about. Laplace transform is all about. Let me just share it. Okay. Okay. Can you see my slides? Do you guys see my slide?
Yeah.
All right. Okay. So this is it. Yeah, Laplace transform is basically okay. Transform meaning what? You know, atomic prime. You know, bumblebee transform. You transform from one form to another. Same thing. Laplace transform. You transform from one domain to another domain. Time domain to spatial domain. Okay. Right. So it was introduced way before by a French astronomer. Okay, his name is Laplace, so that is why we call it Laplace transform. Sekarang I think have you guys learned ECA, electric circuit analysis?
Yes.
You've learned last sem or this sem?
This sem.
This semester.
Okay, this semester. I don't know whether you've gone to actually solving using Laplace transform, but I think for EE students, you know, after ECA they have another like circuit analysis level 2, where they actually learn to solve the equations in the circuits, and rather than solving it, you know, using the way we've learned before, they learn it to solve it using Laplace transform. Okay, so in circuit analysis, they actually use it Laplace transform a lot, also in mechanical engineering, right? So is Laplace transform, Fourier transform, you like it, you don't like it, doesn't matter. It is the basis of engineering. Okay, you have to appreciate it. Yeah. So this is it. You know, when we talk about Laplace transform, you have to basically where's my pen? All right. You have to, okay, this is it. The annotation, you know, Laplace of ft. Okay, this you write it this way. So meaning it is a function. So if you imagine you put in a function in a time domain, okay, a process, which is the Laplace process, right? And you get a function in a spatial domain, Fs, all right? So that is what Laplace transform is about. And by doing this, you will use a kernel which is exponential. This is the kernel, exponential to the power of minus st. Multiply with the function, integrate from 0 to infinity. All right. The old drawings. Now, original. Okay. So this is example 1 just now, done by Fatin. Fatin mana tadi? Ada dua Fatin. Fatin KB, I think. Okay. So this is done by you. Okay. Now this is for a trigonometry function. I'm not gonna go through it, but it is in my slide. You can go through it later when I post it. So why I'm not gonna go through it, because it involves integration, 2 level of integration by parts. And this is how you solve it. Okay. Anyway, bottom line is you know the function. This is it. Okay, I'm not gonna go shifting theory yet. I'm gonna go to this. Okay, can you guys snapshot this, please? please snapshot this. Somebody please snapshot this and put it in our WhatsApp group, please. Can somebody please snapshot and put in our WhatsApp group? Tak ada lagi orang. Please snapshot this, put it in the WhatsApp group. All right, thank you. Thank you, Tan. All right, now if you look here, where is my pen? The pen loves to hide. Dear me. All right, okay. If you look here, this is what being solved by Fatin tadi. Given 1, ft is 1, you get the Laplace transform, which is 1 over s, and our friend you have done for this, you get 1 over s minus a. All right. So most of the time, if I will, kalau saya kata tak, most of the time, we will give you this table. It simplifies it, but you know how you get this table is it is basically from the integration. So this table, keep note, you will use this a lot. Okay, you will use this. This is basically a shortcut to it. So if you look here, so if your ft is cos omega t, okay, if cos you get s over s square plus omega square. If it is sine, atas dia is actually omega over s square plus omega square. So this table is basically, you need to have that is your appendix, okay? You need to have it all the time with you. That's why I asked you to snapshot. Tan has snapshot and put it there. All right, now, the one that I need you to know is that Laplace transform, just like Bumblebee, from car you goes to robot, from robot you goes to car. And in a similar way, Laplace transform, if I were to put in ft into a Laplace process, I will get fs. Okay, now very important, yeah, this is accepted worldwide. Bukan saya suka-suka ya. Time domain, you use small letter f. Frequency domain or spatial domain, you use capital F, all right? So in other way, okay, coming back to Bumblebee. Bumblebee from car to robot, robot boleh go back to car. So in a similar manner here, you can also do Laplace transform where I give here the fs. Okay, I put in an fs, but here rather than I put Laplace, I put inverse Laplace. Okay, so inverse Laplace, the annotation is L -1. It is the opposite, the reverse process. So you should be able to retrieve back your ft, your signal in the time domain. All right. So I want you to get this picture. Time goes to spatial. You can inverse back from spatial to time. Guys, what's the time now? I'm gonna go 12. Okay, okay, you want to take 5 boleh. I'm gonna give you another clips. You go through these clips, yeah? How do I stop this? Stop share. Okay, okay, yeah. Go to my YouTube channel, go to Laplace 2. Okay, berapa minit Laplace 2 tu Laplace 2 tu berapa minit?
8 minit setengah.
Hah? Berapa minit?
8 minit setengah.
8 minit sekarang. Okay, sekarang it is 7 o'clock. You have 8 minutes to review the slide. Come back at 12:30, you take 5. And then come back at 12:30. Is that okay?
Okay,
Boleh
Doktor.
ya? Okay.
Boleh.
Look at that. Come back at 12:30. We're gonna solve that after this. All right. Thank you. Take 5. Okay, guys. 12:30. Are you all there?
Yeah, doctor.
Ada. Okay, semua. I'm gonna tell you who I'm gonna choose. Siapa baru masuk tadi? Izzati, Ceras. Izzati.
Ya, doktor.
Alright, you want to explain?
Kena share whiteboard ke?
Ya.
So, inverse Laplace punya formula is to
This is Laplace transform. We are doing inverse Laplace kan? So kalau inverse Laplace, input dia ialah Fs, kan? Okay. 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 Betul. So tadi diberi, apa yang Fs diberi?
Fs equal to 0.2 S plus 1.4 over S square plus 1.96.
Okay. Now, kalau you all tengok S square plus 1.96, kalau S square tu is plus something, must be cos or sine. Okay, so you cari 1.96 tu, you square root 1.96, what do you get?
1.4.
1.4, okay. All right. S, all right. Plus 1.4 square. All right, correct. Okay. Plus inverse Laplace. Okay. 1.4 over S square plus 4 square. All right, okay. Two cos, okay, omega is 1.4, so cos 1.4 t, good, plus sine 1.4 t. All right, thank you so much, Izzati. Okay, so that is about Laplace transform. Actually, kalau ikutkan, saya nak go through the first shifting theory of Laplace transform, which is what do you call this, the Laplace tree from my slide. Tapi saya rasa korang you had your class and your quiz from Digital Logic, so we probably stop there lah dulu, boleh kah? Is it okay we stop there dulu? Kalau nak pergi module 3 boleh je. Saya boleh pergi module 3 or you want me to stop? Hello?
Continue.
You want to continue?
Continue.
Oh, okay. Okay. Before I continue, I want to bebel dulu. Have a look at this. What is this?
Statistic.
Statistic.
Okay, this is where you put your knowledge, what you've learned. Okay, because is it on? You put your knowledge of engineering mathematics here. So how do you analyze this? Mana screen saya ni? Lama, mana saya nak saya punya screen ni? How do you analyze this? Sekejap dah, how do you analyze this? Sekejap, coming back, share back again. How do you analyze, how do you put your knowledge here? What shape is this? Oh, tengok shape aja. Okay. This is e to the power of 80 exponential e to the power of minus 80 exponential decay. This is exponential growth. Probably you've learned, some of you, many of your case study, I've checked in your project 1, you have done what do you call this? Population dynamics as your case study. Remember project 1, where you present in the YouTube. All right, now if you look here, doesn't matter what the A is. If you remember the RT and R naught, okay, yang kalau the DG Asyik duk cakap pasal RT and R naught is regarding this, alright? So R naught is the initial. Sama lah juga kalau saya kata Y naught. Y naught is usually Y at time 0, alright? Usually, okay? So RT is the variable, it can change, okay? So now it changes. Now I think the RT now maybe varies. Dia ada bagi from negeri ke negeri, but I think it's more than 1.2. Okay, you've learned population dynamics, okay? If RT is basically more than 1, it will go in exponential rate. If it is less than 1, it will slightly decay. Now, this is, if you tengok kalau awak tengok, this is, katakanlah you call this as YT. This is your YT. Okay. So you can assume that you have another Y prime T, which is the differentiation, which is equivalent to RT itself. Because RT, dia describe the kecerunan. So anything that describes kecerunan is basically the differentiation of it, okay? Katakanlah it is of some formula, but we call it RT, so it's actually Y prime T, some form of Y prime T. So now the one that I want you to note is that R prime T, dia tak ada macam, it's not like you go up here, suddenly it goes down. No. You understand what I'm trying to say? We are talking about R prime 3 ni here, okay? Dia punya what do you call this? R is basically how much it can affect, it can spread to others. So if it is like, you know, if if katakanlah now we are at 1 point, this is 1, and now we are 1.2, okay, katakanlah 0.8. It's not like it's gonna, it isn't like, because it is also some form of derivative. It describes the slope. So the slope doesn't go like that, you know, suddenly like that. It doesn't go like steps. So it katakanlah if the MCO 3.0, which is now what we are going through here, is effective, it will decrease, but it will decrease gradually. What does it mean? What does it mean? Okay, I'm gonna clear all drawings here. Stop sharing. Let me just stop share. Let me just take a clean whiteboard. What does it mean? I'm just trying to put, you know, let's us be creative. Apply whatever we have learned in mathematics inside this. Okay, we are talking about RT here. This is time. RT, because RT describes kecerunan. Okay, how from the actual Y here. This is the Y just now, the one that you seen now is this exponential growth. So this is the YT. RT is basically one of the slope. Okay, slope is kecerunan. Okay. So what does it say here? Katakanlah now we are, assuming I don't know what's the rate now, but let's say 1.2. Ideally, let's say we want to go below 1. Below 1, we want to go 0.8. Okay, we want to go here. But the thing is that it won't go like this. It won't go like that. Okay, in actual way, it is actually going this way. You know, if it goes like this, sama ada dia curang ataupun dia landai, that is how strictly we adhere to the MCO. But what I'm trying to say is here, it will take some time before it goes to below 1. So in other words, selagi mana whenever RT, this is where you have to know, you know, whenever RT more than 1, it will always be exponential. Cuma it will be, katakanlah dia 1.1 compared to 1.2. Okay, what is the difference between 1.1 and 1.2? 1.2 is more steep, 1.2 less steep. That is the only difference. So if we look here back into this diagram, yeah. Now, if we look back into this diagram, so let's say I'm here, I'm going gradually to here. So waktu sini, it is still positive, more than 1. Can you see this part? It is more than 1. Okay, sini more than 1. So in other words, whatever logically, yeah, if you use your maths here, logically, this is T, this is YT. So logically, if this is what we do now, we don't go like immediately like this. So, but there is a period of time where it is still RT is more than 1. So it will be gradually. So what does it mean here? What does it mean here? Selagi dia more than 1, it will keep on increasing. Sama ada dia steep atau tak steep, itu saja beza dia. So what does it mean here? Anybody? Are you guys asleep? Or are you guys with me? Alright, okay. What does it mean here? Saya tak nak ceramah. I'm just trying to adapt your maths skill towards the statistic that the data that we have now. What does it mean here?
It will keep increasing until it reaches this maximum point and then it will go down again.
Yes, it means, okay, the worst is
Has
yet
not
to
come yet.
come. Yes. It will take some time before it peak, before it reduce. That is what I'm saying. If now we are reaching 7K, wallahu alam how far it will go, depending on this, how steep is the RT, how steep is RT will decay. If it is steep, it won't peak that high. If RT need decay very slowly, it will take a longer time before it goes down. You see what I'm trying to say? The thing is that it will get worse. So now, I'm going to relate this with, currently we are here, and now ICU utilization is more than 100%. If it goes any further, what do you think it will be? I think beberapa hari sebelum ni saya tengok it was 90%. Above 90%. And I think yesterday ke apa, it's already over 100%. So what does it mean? What does
People
it
will
mean?
die.
Huh? People die. People die. It doesn't matter.
Even
What
more
does
will
it mean?
die.
No. If you remember Italy, if you remember India, you remember even UK, Italy, because the ICU, you have to remember, ICU is not just about bed. Okay, I think those who says just add another bed, you are just a dumb fool. Okay, it's not just about bed. It's about the whole thing. The bed comes with the whole utilities attached to it, and also the team members. We are talking about the staff, the doctors, etc. Which is the doctor trained for ICU is different. The staff, the nurses, etc. trained for ICU is different from the team which handle the normal ward. Okay. So in other words, when we are talking about the capacity of the ICU, it's not just the bed. People, if you say add additional bed, no, it doesn't work like that. You have to consider the staffing as well, the whole equipment, etc. So everything comes in a package. So if you have that capacity, if we cannot increase that capacity, even okay, remember, Malaysia is developing countries. If we compare with Italy, Italy is what is a developed country. So even in Italy, when they reach that level, what do? They get to decide. Kata kalau they exceed certain point, critical point, what do? The doctors get to decide. Decide what? Who gets to be saved, who not? What does it mean? Okay. If you are, let's say, 20, 30 years old, you are fit, okay, you might be saved. If let's say you're talking about your parents, your grandparents, 60, 70, they might just put you in the normal ward until you are off. You get what I'm trying to say? This is where when you look at the data, you have to look. You have to kaitkan, not just normal statistic. Normal statistic is a normal case. Where? Hold on, I'm gonna erase this, clear all drawings. You have the initial data when you see every day, which is the normal. This is the normal statistics of the positive COVID. From here, you should be able to relate this with the RT curve. From here, you should be able to relate with the ICU capacity curve. And you know when it exceeds a certain threshold, which I think will be very soon, because RT cannot go drastically drop like that. It doesn't work like that, It will gradually reduce. Dia nak gradually reduce, you have to see the worst. The worst is where the doctor decide who will be safe and who they will let. Kalau dah tua sangat tu, that's it lah. You're done. Okay. So that is how severe the situation is. Okay, I'm not gonna nag. I'm not gonna nag. You all know your responsibility. I know my responsibility. I'm just trying to relate mathematics here. All right. Clear all drawings. All right. Okay. Now, you want to go to first shifting theory? Okay. Let me just go to first shifting theory. It is even in my slide. Yeah. First shifting theory. First shifting theory. First shifting theory. First shifting theory. All right. This is first shifting theory. All right. Write this down. Write this down. Yeah. The first shifting theory says, okay, now the thing about Laplace transform, there's a whole lot of formulas, okay? If you are, alamak, benda ala ni selalu tak keluar lah dia punya window. I'm gonna, mana window dia? Okay, and whiteboard, annotate, where's my, oh, can I write? No, cannot. Yeah, stop share. The annotation board doesn't comes up. Let me see. Okay, annotate. Now the first, I'm gonna go back. The first shifting theory. Let me go back. Hold on. Okay, this is the first shifting theory. The thing about where were I? The thing about Laplace, there's a whole lot of formulas, and one is the first shifting theory. The first shifting theory said, okay, if you're again, if you remember here, this is your ft goes into your Laplace transform, you get fs. All right. Now, assuming prior to that, your ft is being multiplied, this is your ft, by a function which is exponential of et. Okay, e to the power of at. If it's being multiplied here, all you have to do here, meaning first shifting theory, it is being shifted by in the spatial domain s minus a. Okay, you get what I'm trying to say? Yeah. If your signal, the original signal, is being multiplied with a kernel function e to the power of at, then your Laplace signal will be shifted. Okay, fs minus a. So write this down. So in other words, fs minus a is Laplace of EAT multiplied with ft. Can you write this down? So if you want to put the inverse of EAT ft is what? Silap. If the inverse of fs minus a is EAT multiplied with ft. All right. So write this down.
Betul.
Yeah.
May I ask why we need the first shifting theory?
This is the theory, the first shifting theory. If you want to do, okay, never mind. Okay, you want to show, okay, we will show why it is being shifted. Okay, good question. Let us do again. I'm gonna, okay, let me just mana clear all drawings. Okay. We go back to the theory, yeah, Tan? Good question. Let me go back to the theory. Okay, let us go back to the theory. I'm gonna use red. Okay. Now, remember tadi Fatin Shah Alam. What is the formula, Fatin Shah Alam? Laplace of ft. Apa formula dia, Fatin Shah Alam? Integration from?
Equals to from 0 to infinity.
Okay.
ft times exponent to the power of negative st.
Okay, dt. All right. Now, let's say your ft is basically 1, and then you have gt, which is exponential at, okay, and ht, Allahu Akbar, yeah, your ht is ft minus gt, so you get exponential to the power of at. Now I want to find the hs. Hs is basically Laplace transform of ht, which is 0 to infinity. So what is my ht? E to the power of at multiply with e to the power of minus st dt. Okay, I'm gonna make this in terms of exponential decay. Yeah? Exponential decay, let's put it from 0 to infinity, e to the power of negative. So here is s minus a t. All right, dt. Ini macam yang siapa ni buat tadi kan, betul tak? Ini this is you buat tadi kan? So the answer here is 1 over s minus a. Betul? This is what you did just now. Now, if you look here, look into the table, what is, if ft equivalent to 1, what is fs? Look into the table. This is Fatin.
1 over S.
Fatin apa? Fatin lagi satu tu. Fatin Ganu, Fatin KB. Fatin KB tadi buat 1 over S. Betul? Now, what is fs minus a? If this is fs, s minus a is 1 over s minus a. Betul tak?
Betul.
Betul? Now, if you look here, is this not similar to this?
Yes.
Yeah? So can you see that this is being shifted?
So
This
like
is-
that they name as
Yeah.
first shifting.
Yeah, so basically
Okay.
it is a theory, but if you work out based on this formula, you will find that it satisfies the theory. You get what I'm trying to say?
Yes, doctor.
All right, okay. Okay, so that is what I'm trying to say here. So in other words, for your sake, I think all you have to know is that now we know the formula, which is if you have a signal ft and you do a multiplication with another kernel, okay, so the Laplace transform will be fs minus a. All right. Now, having said this, so in other words, if I were to put it into write up, so Laplace of e at ft is equivalent to fs minus a, and inverse Laplace of fs minus a is equivalent to a kernel EAT f multiplied with ft. So this is known as the first shifting theory. Why it is shifting? Shift. This means shift. Shifted. All right. But remember, it is being shifted in the spatial domain. Multiplication in the time domain. This is multiplication in the time domain. Multiplication in the time domain, shifted in the frequency domain. So shift in spatial domain. Sebab nanti you will also have second shifting theory. That is the opposite. You shift in the time domain pula. We'll go to that later. All right, now, clear all drawings. Let's go back to our slide. Nak dekat pukul 1 lah korang. You want me to stop? Stop lah, I know some of you are very motivated, but I think we already won. I'm gonna give you. We can continue this on Thursday. It's already 1 o'clock anyway. We are done. So we stop here. Is this okay?
Okay, Doctor.
Okay.
Yes, Doctor.
Yeah. Don't forget to tanda tangan dalam attendance, yeah. Okay, that's it, guys. You know the severity of the COVID-19. Be safe. Take care of your family as well. Thank you very much. Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam.
Thank you, Doctor.
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 Selamat Hari Raya, nah.
Hari Raya.
Yang kat Kajang ke, yang kat Bangi ke, sorry lah. No open house, unfortunately. Duduk rumah masing-masing. Okay. Thank you.